Let's learn how to use MQTT protocol with NodeMCU ESP8266. In the end, we will control LED connected to NodeMCU and monitor a temperature sensor data using publish and subscribe mechanism of MQTT protocol. This video is sponsored by Altium. Now you can use Altium PCB design with Octoparts. Octoparts offer you most up-to-date part data like specifications, datasheet, CAD model right into the design environment. So try Octoparts and Altium today with the link given in a video description. And I'm sure you will enjoy working with Altium and the Octoparts. Our NodeMCU doesn't know MQTT protocol, so we have to install the MQTT library. So we have to go to Sketch, include library, and then we have to click on manage libraries. So once we click on manage libraries, it might take a couple of minutes or seconds, and then the library manager shows up, and then we have to search pub sub client and then hit enter, and you will have to find pub sub client by Nick O'Leary. So somewhere in a search section you can see this is a pub sub client by Nick O'Leary, and by default it takes the version, the latest version of the MQTT library. We don't have to worry about the version of the MQTT library, that's a pub sub client. So just click on this install button, and this basically install the MQTT library for NodeMCU ESP8266. So once the library is installed, we have to close this library manager, and now we can go to file, examples, and we have to scroll down till we see pub sub client, and then under pub sub client we can able to see MQTT ESP8266. So this is an example project, so let's click, so it's open up, and now we can use this example project as a reference point for us. So I'm just going to resize properly, and then you can see here's an example project. And what I'm gonna do is I would just remove those comments because the clean code will be much better when I explain. Now you see this ESP8266 Wi-Fi.h header file is not detected. It shows in a black font, and that is because we have to go to tools and make sure the board, we have to select NodeMCU 1.012e module. The moment we select the right board, you can see the color changes, and now our Arduino IDE detect the Wi-Fi header file and also the MQTT client library, which is in pub sub client.h. That's the C library for NodeMCU ESP8266. It's an MQTT library. Now, since NodeMCU is the Wi-Fi device, we have to put the SSID and password, so our NodeMCU will get internet connectivity. So in my case, in a double quote, my SSID is binary update, so I would going to put the SSID, that's the name of my internet access point, or maybe hotspot, whatever internet that you want to use, and then there will be a password, and in a double quote we have to give the password. It's a best courses in my case. And then of course we need a MQTT server, and MQTT server that we want to use. And I would not suggest you to use this broker.mqttdashboard.com because this is very common server, MQTT server used in every other MQTT project ready example code, and if you upload the same code then it will be a problem. So we will find a new MQTT server, and for my favorite MQTT server, just open a command prompt, and as I said, you know, we need a server. So to get the server, we will say ping test.mosquito.org. this is the free to use MQTT broker or MQTT server. I would say MQTT server, so 5.196.95.208. so this is an IP address that we will use, so I will just copy, and then I don't need this anymore, so I'll just close it, open my Arduino project. We will have to put in a double quote IP address of the server. It's a 5.196.95.208, or you can in fact write test.mosquito.org. that's absolutely fine. So let me just comment test.mosquito.org. so this is the server, MQTT server. So if you want to know more about the server, you can just copy and maybe just put on a browser, and let me just show you if I can open Chrome for you. So Google Chrome, and just put, and this is basically the information about the MQTT server we are using. It's a test.mosquito.org, and you can see the port is 1883 for MQTT unencrypted. But it doesn't matter, we don't need this anymore, this old things. We need this IP address of the server, and we get it. Either you can put this IP address or you can put the name of the server. Both are absolutely fine. Now if we scroll down further, then we can able to see that there will be a topic, and you can see we are using a built-in LED which is basically connected to GPIO2 on NodeMCU ESP8266. So when we publish a message 1 on a topic that is basically in topic, so if we scroll down somewhere, you can able to see client.subscribe to, in a double quote, we have in topic. So I would rather make it more readable. I would just say device/LED for this is the topic to control the LED, which is onboard LED GPIO2 on NodeMCU ESP8266. So what this code basically does is, whenever we publish the message 1 on device/LED, okay, this is the topic that NodeMCU will subscribe, then what happens is basically the LED turns on. Now it will generate a logic low, but it's given here a reason why when we publish message 1 it makes the logic low, and logic low basically turn on the built-in LED, because you can see built-in LED is active low on ESP01. okay, so logic low will turn on the LED and logic high will turn off the LED. So when you publish message 1 on device/LED topic, then the LED turns on, so this will light up the LED. And if you publish, let's say, a message 0 on device/LED topic, then the LED turns off because it generates the logic high on built-in LED, that's GPIO2 pin. So that's basically how we're going to control the LED on NodeMCU ESP8266. So if you scroll down further, then you can able to see there is an out topic, and for out topic to send a sensor data, I would rather give the name device/temp for temperature, and then I would just say that MQTT server is connected. Okay, so this is basically just a message it will throw. Even if you comment this line of code, it really doesn't make that much sense, but the real magic is happening here in the loop function. So here in the loop function, what is happening is send this message hello world, and this value keep incrementing. So the value variable keep incrementing, and it will basically publish those messages on out topic. Now out topic we have to change device/temp, because later on we want to send a temperature data. Now if you just want to modify this code for sending a temperature data that is connected to NodeMCU, then I would rather look at this value variable. Okay, and this is a global variable. So look at this integer variable value is equals to 0. And what I'm gonna do is, because we have connected an LM35 temperature sensor on A0 pin, rather modify this code, and I would say value is equals to analog read, and I would say A0, and because we have connected a temperature sensor LM35, why not we should multiply 0.32. That's basically converts the temperature in degrees Celsius, and it will be stored into this value variable, and then it will print every time onto the serial monitor. So I would just make this temperature is, and then it will make the pound sign, and then it will just throw the number, whatever the number is. I mean, if you just want, you can just put double dots, and I think looks absolutely okay. I mean, this part of the code basically will publish the temperature to the MQTT server, and so NodeMCU will send a temperature data in degrees Celsius to the MQTT server, which is this server on the top. We said 5.196.95.208. And then as far as the control goes, the LED control goes device/LED. So this is the topic that we have to subscribe. So when somebody send from server 1, then it will turn on the LED, and when somebody publish a message 0 on device/LED topic, the LED light up. That's how, you know, NodeMCU will going to control the LED and send and publish the sensor data on device/temp topic. So device/LED topic is for controlling, and this device/temp temp is the topic for monitoring. That means we want to send a temperature data. Now I already have connected NodeMCU, the laptop, but we need a MQTT client for this. And one of the most simple client that I want you to install. Of course, we need this to be on a Google Chrome. So we have to install the MQTT client. That's basically an MQTTLens. So I will search MQTTLens to install. And we get to see this Google Chrome extension. So this only works with Google Chrome. You have to have a Google Chrome for that. To keep it simple, we will going to install this MQTTLens. So click on MQTTLens and it will take you to the Google Chrome app. So just click on add to Chrome and this basically quickly installed. It asks us to log into our Google account. So we just have to click on add app and then close it, and it's basically downloading. In lower left corner you can see, so it's adding basically to the Chrome, and now you can see MQTTLens shows up. So when I click, you can see the software opens up, right? So this MQTTLens is the software or the MQTT client that we will use in order to control the NodeMCU or ESP8266. So I will take the edges and fit in properly into the screen so everybody can see every corner of the MQTTLens when we will have to configure the MQTTLens. So click on this plus button. That's basically to create a connection. So it asks us to create a connection name, and you can give any name. I would basically give the connection name as a binary updates, and we need an IP address of the server. Rather, I would go to my code and I would copy this IP address. I would prefer all the time to put the numbers of the server rather than the name. So just copy the IP address of the server, just paste it here under the host name. So we want this MQTTLens as a MQTT client to connect to this MQTT server on 1883, which is an MQTT port. And then we can scroll down. We don't touch anything. You don't need to do any advanced settings. We might talk about the settings a little bit later in another video. Just right now click on create connections and you can see connection is created. It says the green color icon. If you hover over your mouse, it says connected. So if it stays red or some other color, that means something is wrong and something is not up to the mark. So what I'm gonna do is I would just keep this MQTTLens opened up. Okay, just maybe make it a little bit small so you can probably see one corner. I open MQTTLens and I would open the Arduino IDE side by side so you can see what's going on here. And basically because the code is ready, go to tools, make sure the port is selected properly, COM4, and board we already have selected NodeMCU. That's basically 1.0 12E module, and we can just upload the code and see if we can able to monitor the temperature sensor data, and we can even control the LED, which is a built-in LED, onboard LED on NodeMCU, which is a blue color LED. I hope you know. If you don't know the basics, then you probably go back and check our other videos about NodeMCU. We have a complete series for video lessons and they are very effective. You would get to learn a lot of things about IoT and NodeMCU and about MQTT protocol also. So I have given a link in a video description where you can learn more about MQTT protocol. So the code is uploading. You can see in lower left corner it's still uploading the code. So we have to wait till we see done uploading. It takes some time, a little bit of time, and you can see now in a lower left corner done uploading. That means the code is uploaded. We go to tools and just open serial monitor. Now the baud rate here is 1150-200. So just select the right baud rate here, 1150-200. And once we select 1150-200, now you can see the data starts coming up, publish message. Now, how can you confirm that NodeMCU ESP8266 is connected to internet? So just press the reset button on NodeMCU and then it says connecting to binary updates. That's our access point. That is our internet. And now it says Wi-Fi connected and IP address is got by NodeMCU and attempting MQTT, it's connected. And now you see the data starts streaming. I would just minimize the Arduino IDE and I would just keep it open, the serial monitor, and on a subscribe section, you remember in our Arduino code, just look at the Arduino code and we have this topic device/temp, right? That's where our sensor data is coming. So basically we go to subscribe section on the MQTTLens, just right click and just paste device/temp and then subscribe. And now I can just make it a little bit long so you can able to see. Now the temperature data starts streaming. You can see the count is increasing, when in fact look at the timestamp, and the temperature is coming as 27. Now if I rub the flat surface of the sensor, so let me rub the flat surface of the sensor, and you can see the temperature starts rising up. You can see on MQTTLens it's 28. Now it's 28, and in MQTT and in serial monitor also you can see the temperature starts rising. It's 31 now, and on MQTTLens also it's coming as the 31. So it's working fine, right? Now let's check to control the LED. So if I take the topic for LED, and if you remember, we have the topic which is basically device slash LED. And if we publish the message 1, so we have to publish message 1 on device slash LED topic. Make sure you don't press enter or something unnecessary. We have to send one, only one, right? And so we just write 1 because you have to publish the message 1 on device slash LED, and then click on publish. And now you see the message arrived is 1, and the LED lights up. You can see here on the hardware side on serial monitor we get the 1, that means LED is on. Now when I send 0, when I publish the message 0, then the LED goes off, and we receive here the message 0, right? So to control the NodeMCU ESP8266 using mobile app, we have to install this Android application called MyMQTT. You just open this app. It gives you this kind of view that choose what to allow MQTT to access. On a lower right corner there's a continue button. We click this continue, and it just gives us a pop-up. We say okay, and now you can see here we have on the top left corner there's a dashboard, and there's a back icon. So when we click on that, it takes us to the settings, and you see there's a setting button here. So I click on setting, and then you see we have to fill up quite a few parameters. Now the first parameter is the broker URL. That's basically an IP address of our MQTT server that this MQTT client, that is MyMQTT, should connect to. So 5.196.95.208. This is our MQTT server's IP address, and the down below there is a port number. So the MQTT port is 1883, and the username and password, we don't have to fill in anything. Just click on save, and then once it is saved, it says save settings successfully connected. And in a top left corner there's this icon, back icon. Click on the back, and then you see it turns out to be green, and server's IP address MQTT server 5.196.95.208. I think we have to take our hardware. So here we have a NodeMCU, and there's this onboard LED. I would just click on reset button once before we publish, and then we will go to publish in the mobile app. And then here on a topic section, I would going to put my topic. It's a device slash LED. And then in a message I enter 0, so I enter 0. So publish message 0 on device slash LED topic, and click on publish, and you see the LED on the board goes off, right? So that's basically how you turn off the LED. Now if I publish the message 1, and if I click on publish, you see the LED lights up, onboard LED. I hope you can see this LED lights up, right? So if I publish 0 back again, the LED goes off. If I publish the message 1 again, the LED lights up. Now if you want, you can connect external LED. So I connect this external LED to D4 and ground, and that's basically the other way around, right? So maybe I would publish 0, so that's basically turn off, and you see the LED lights up. External LED lights up, and the built-in LED goes off, right? So if I publish, let's say message 1, so that's basically turn off the external LED and turn it on the built-in LED. But it doesn't matter, this LED is not that much important. Now let's check the subscribe. So we have to go and click on top left corner, there's a back button, and then there's a subscribe section. So click on subscribe, and once we go into subscribe, there's a topic. There we will type device slash temp. That's the topic where we are getting temperature data. And then I click on this add button here, and you see the topic is subscribed and added. So on the top left corner I click on back, and now on the dashboard, if I click on dashboard, you see the data starts streaming. So 27 degrees Celsius, right? So if I rub the sensor, look at this, I am holding the sensor flat surface and rubbing, and you can see the temperature start increasing. Now it's 30, now it's 31. If you are new to MQTT protocol and IoT, then don't forget to watch the other videos. The link is given in a video description. Believe me, they are awesome. I hope you have found this video educational and entertaining. We'll see us into the next video lesson. Bye bye for now.